Well, what we know is that some reactions occur much faster than others. So, for example, may remember from last year when we were looking at the trends in the periodic table, the reaction of potassium with water was very fast and was an exothermic reaction, whereas the reaction with calcium with water was much slower. And so what this means is that some reactions are faster than others, and it comes down to our threshold energy. Now, in this case, we have simple monovalent atoms also reacting, so that helps. And we can see the impact of nature on our Maxwell-Boltzmann curve. So if we look at our threshold energy with calcium, we have a small fraction of particles with sufficient energy for an effective collision. Whereas if we look at our potassium, we have a greater fraction of particles with sufficient energy for an effective collision. So as a result, since more particles of potassium have enough energy for an effective collision, it will have a faster rate of reaction. Here we have another example where we're going to react an iron 2 ion with permanganate or an oxalate ion with permanganate. And we can see that our iron 2 ions basically react instantaneously with our permanganate. And this is because of the simple nature of the iron ion. Whereas our oxalate reaction occurs much slower. In fact, we had it all mixed together, there was a delay, and then it slowly changed. And this just has to do with the fact that iron 2 ion is a simpler ion, so it doesn't have to worry about the orientation. Whereas an oxalate ion, because of its bulky size, its orientation matters. Also, with our iron 2 ion, I didn't need to break any bonds, unlike the oxalate ion, which did have to have bonds broken when it reacts. So these come together in influencing how fast our reaction can occur in terms of the nature of the things. Simpler monovalent things react faster. State also plays a role where if all of my reaction particles are gases, there'll be a faster reaction than if one of them is aqueous or one of them is a liquid. Okay? But it comes down to the orientation. And simpler particles or gas particles don't have to worry about the orientation as much as solids or aqueous.